in this talk, I will present the preliminary results of one of the projects I'm working on in my PhD, which is applying random forest to this photometric survey called JPLUS. So what is JPLUS? JPLUS is a photometric survey located in Spain. It's carried out with 80 centimeter telescope. And we have a first data release available since last year. So this is the filter system of JPLUS. We have 4 scissors in common with the slow one. And we have another broad, narrowband, and intermediate. Some of the intermediate filters were designed to match some interesting spectral features. This is the field observed so far by this survey. This is and the total area is 1,000 square degrees. And what? Okay, what I did with this first data release is try to apply this random forest machine learning algorithm, in order to try to classify things and make regressions to estimate stellar parameters. So the idea is I built a model using as an input all the possible colors based on this photometric system. So in total, the inputs will be 66 colors based on these JPLUS filters. As an output, I can end with a morphological classification and the regression of stellar parameters. So in terms of classification, there's a problem photometrically because quasars cannot affect the identification of faint stars. Since I'm interested in working with stars, that could be a problem to me. So I need to get rid of the quasars and have the best clean sample as I can. One way to do this is with calibration in flux. There is a possibility in order to try to classify different things. So we have here this different spectral class of stars and galaxies and quasars. But instead of that, what I did is to perform a classification random forest model, and I got this. This is a naive model, and this is the best naive model I'm using. So I'm open to suggestions to improve this model. And this is the future importance. If I go back to the old stuff, to the old skull, I can use one of the features and make a color diagram plot in order to test if this algorithm is performing good selection. So I have these galaxies, but when I plot the stars and quasars, it seems that I can use this color diagram plot without applying any model in order to classify stars from quasars. But unfortunately, the galaxies were hidden. In terms of regression, I basically do the same thing in order to estimate effective temperature using a cross mesh with Sloan data release 12, and with Lamos data. So what I did here is train a model based on Lamos data and apply predictions, applied regression to the other one in order to see what happens. And both of them shows some kind of correlation with some dispersion based on this naive model. And I also did the same thing, but in order to estimate metallicity. So in the x-axis is the metallicity estimated by random forest, and in the y-axis is the metallicity adopted by both by Lamost and by Sloan, the pipeline of Sloan. Here with the metallicity, what I did is the opposite: train a model based on Sloan data and apply to predict this metallicity on the other data set, the Lamost data. If I just focus on low metallicity stars, since I'm working, this is a project I'm working on my PhD, this is what I got. This is the metallicity predicted by the model versus the metallicity measured spectroscopically by the Sloan survey. So the idea here is, if I focus on different things, I can see that maybe this model can be used with improvements in order to estimate metallicity in a wide range of different class of stars, and yes, that's the basic idea. I'm doing this because I want to select good candidates for low metallicity stars in order to test, confirm them with high resolution spectroscopy. Okay, so just a quick summary with random forest. I use random forest because, to be honest, I'm just a beginner in this field of astroinformatics. So this is the first machine learning algorithm I learned. I'm playing with it. So I just testing this algorithm in order to make these predictions, and I found it has the potential to perform good classification and also estimate stellar parameters. Of course, we need to improve the accuracy of the models, maybe with tuning and the main idea for me is to come up with a model that I can use to select these candidates of extremely metal poor stars, which is stars with metallicity less than -3. So I'm open to suggestions and any comments, and I think that's it. Thank you.